Good afternoon, sir.
Good afternoon. Uh, so we were discussing about IPv4 header in the previous class, right? And after that, we moved on to the addressing part, right? So in IPv4, we use classful addressing. So I told you that the addresses were uh, assigned in different classes. So there are classes like class A, class B, class C, class D, and class E. So in each classes, a pool of addresses were assigned depending on like uh, like suppose if some large organizations are there which may have like class A networks, larger organization with larger number of networks and each with uh, each fewer networks but with large number of hosts like in class A. Similarly in class B you can see that network bits are 14 bits while host bits are 16 bits. So medium number of networks each with medium number of hosts. And class C which you find which we use is generally that is network is there are multiple networks, larger number of networks each with a smaller number of hosts. And the class D was reserved for multicasting, right? And class E was not used at all, right? So how you can see that in class A there are 32-bit global internet address network part and the host part. I told you that the IP address is uh, divided into a network part and a host part. So in class A starts with binary 0, all zeros are reserved, right? You can see here 0, then if you keep all zeros, right, you will get 0 like the first address. Okay, whenever you have to assign addresses like in class A or class B or class C, always remember the first address. Okay, when all the bits are 0, that or the first address, okay, in each len will be reserved, right? And the highest address will be 0 while keeping all other bits as high. That is basically using for loopback, or you may say that it can be used for broadcasting also, right? So that is reserved, right? These two addresses will be reserved, so there will be potential uh, the address range will starts from 1, right, to 126. So there will be potential 126 addresses, right, in each network, right? Each network will have 126 effective hosts, though there will be 128, but in each network one will be dictated to reserved, one will be reserved and another one will be set for broadcast or loop checking, right? So this two will be reserved. Similarly in class B the range starts from 128 to 191. So in this you can see that there are 2 to the power of 14 network addresses, right? So each network, you can imagine that 4 billion was not a less number, right? When we are saying 2 to the power 32 addresses in IPv4, 2 to the power 32 is around 4 billion addresses. But the 4 billion was not a small number that we soon get depleted with these many addresses, right? The main reason of depletion of address space was that we assigned it, but because each device is assigned with a unique IP address, so most of the addresses were not used and they were wasted, right? So if I say about class B, you can see that the first bit and the second bit is reserved 10. It starts class B addresses starts with 10. There are 14-bit network address, right? And there are 16-bit host address, right? So there are 2 to the power 14 networks are possible, right? That many class B addresses are possible, networks are possible. Each network will have 2 to the power 16 host, right? 2 to the power, how many hosts one network will have? 2 to the power 16 minus 2. Why I said for class B minus 2? Can you answer? Each network will have 2 to the power 16 number of hosts. Minus 2 is how much? Why I subtracted 2?
One for broadcast.
And one for one lower address is reserved, right? 00 is reserved, right? One lower address is reserved. So each network, you can see that there is a 14 bit, right? 14 bits you will put like 0 0 0 0 with 1 0 fixed. 4 5 6 7 8 9 10 11 12 13 14. So your first network is this. In this network you will have 2 to the power 16 hosts, right? So each network, each host will with 16 bits, right? The first host with 16 bits, right? Then 0 0 0 0 1. This is the host number, right? 1. Like that you will have 2 to the power 16 host. In that the first address will not be used. I'm saying about one network. And then the last address where you will have all ones, right? That is also not used. So like that each network will have 2 to the power 16 minus 2. So 2 are reserved. So always remember the total number of hosts will be depending on the host address bits minus 2. Similarly, in class C, you can see that there are 2 to the power 21, right? The 3 bits are reserved, 21 bit network address, right? And remaining 8 bits are of host address, right? So there are many networks. 2 to the power 21 networks are possible, and each network will have how many hosts?
2 to the power 21 minus 2.
2 to the power 21 क्यों होगा? 2 to the power 8 minus 2 ना? 2 to the power each network will have 8 hosts ना?
Yes.
2 to the power 8 minus 2, so that will be 254 hosts will be there in each network, right? So now since the addresses were depleting because of this assignment of class wise assignment of addresses, so what was the possible solution was to have subnetworks, okay, and subnet mask, okay. Like in VIT when we because suppose as a large organization, rather than having multiple lanes, right, we can have like from the outer point of view, like suppose this is BIT, right? But from the outside point of view, this is only a single network, right? But in BIT we have multiple networks, right? We have n number of networks in BIT. But whenever whenever some outside organization is looking, it is looking like there is one BIT, right? So just to save the number of IPs, right? To save the number of IPs, what we have done, we have brought the concept of subnetting. So the site looks to rest of the internet like single network, right? Each LAN assigned a subnet number, right? So from the rest of internet, okay, this is the rest of the internet. Any packet is coming from, just a minute, from this side to this router, okay. तो हम लोग क्या कर रहे हैं, हम लोग उसको locally route कर रहे हैं based on this subnet number. We have divided the network into, already we have multiple networks, so each network has been given a subnet number, okay. So whatever this 32-bit address, IP address is coming, that is again divided into, so on that suppose a packet, suppose a datagram is coming to this router, right? What this router will do, how will it identify? We have multiple subnets, and on each subnet we have number of stations, right? So how a particular station will be identified on a particular subnet, right? So what we do once the datagram arrives at this router is equipped with a subnet mask. That subnet mask is created, right? That subnet mask is created. There are some default subnet masks for each class, class A, class B, class C, class D, and some of the subnet masks are created by the network administrators, right? So if you see your internet options, if you go to the internet options, you will find there will be a gateway address, there will be a IPv4 address, then there will be a subnet mask, okay, which is being applied by the router to know about the subnet number on which a host is connected and the host number. Okay, in this network there may be many hosts, right? So so you can see here that this is the configuration, right? This is the network, this is the subnetwork, and from the outside a packet arrives at this router, right? So you can see that there is a net ID and there is a subnet ID. So we have a, so this packet arrives with the ID 192.228.17.32, right? So how will it be reached back to the correct host? So for that, first of all, on this IP address, a subnet mask is to be implemented. So once a subnet mask will be implemented, it will provide you some portion. Actually, this host part, this is what you can see 192.228.17, right? This is what it's which class? It's which class address? Can you say? This address belongs to C. So you can see in class C, the first 24 bits are reserved for the network, right? So 192.228.17 are reserved for, they are specifying the network, right? They are specifying the network ID. And again, this host field is again divided. This host field, this is what? The host ID, right? This host ID is further divided to give the subnet number and the host number, right? So this host ID is further divided to simplify this to get the subnet number and host number. So let us see. It is not there. Okay. So with this, suppose if I take a subnet, so I have to first take a subnet mask, right? Okay, I think it is not there. So I will say first of all, what is subnet mask? So subnet mask for class A, I am saying about the default subnet mask 255.0.0.0. So that means once you apply this subnet mask, there is an AND operation performed with the class A address. So you get back, this is what 255 means what? The first octet, right? If you write in hex, it is FF. So it is all ones, right? So out of the 32 bits, the upper 8 bits, which are all one, will give you, because the network ID is what in class A? 8 bits, right? 0 is fixed. In class A, 0 is fixed. Network ID is of 7 bits, right? So it is totally 8 bits and 24 bits were used for host, right, in class A. So this, once you multiply with this FF to this, you get the net ID in return, right? So I'm first writing the default addresses for class B. It is 255.255.0.0. Then class C, it is 255, right, .0. So this gives me this is a default subnet mask, right? Default. Right. So similarly for class D, which is used for multicasting, it is 255.255.255.255. So suppose if I take a subnet mask, right? Because I have to see with respect to that diagram, otherwise anything can be given. Yeah. So with respect to that example, okay. So if you have to choose any practical thing that you can choose 255.255.224, 192, any subnet mask you can choose, right? So as I told you that how many subnets will be there and how many hosts are there on each subnet, that will be identified, that will be determined from this host bit, right? So let us see for the IP address, which is this IP address 192.228.17, 192.228.17.32, right? So if you write this in this in the bit form, how will you write? 128, 64, 192, and then all zeros. 2, 3, 4, 5, 6 dot 228, 192, 128, 164, 32, 16, 8, 4, 4, then 2, then 0. ठीक है, and 17, right? 17 is 0, 0, 0. So this is 128, 64, 164, 32, then 16, then 8, 4, 2, 1, right? Then the last one is, थोड़ा छोटा लिखते तो अच्छा रहता. Okay, I am writing it again. IP address 192.228.17.32 can be written as 11.11 64 32 16 8 4 2 1. If it is wrong, please tell me. 32 is okay. I have just written it in the binary representation of this IP address, right? I have taken a subnet mask. See, this is a default subnet. Okay, I can take any subnet mask, that is 255.254, right? So you can see that once you have this, so this is all ones. ज्यादा हो गए, 9 हो गया, 64, $32, 224, then 0, 68, 4, 2, 1, right? So 8, 2, 3, 4, 7, 8, 8, and this is 224. You write 224. 224 is just like I have written it 228, so it is 192 plus 32. So this is 224. So once you do bitwise AND, okay, once you do bitwise AND operation, what you get? You get the same thing for these three, because it is multiplied with FFH. So you get the same thing here, right? 192.228.17. But once you do AND operation of this, what you get? You get, these are all zeros. This is 001. So you get 001, right? 001, 1, 2, 3, 4, 5, right? So always remember, once you got this, after applying the mask, from where the contiguous zeros starts. Okay, before this portion is gives you the subnet number. Okay, so this gives you the subnet number. Okay, so if you put, okay, and to identify the host number, right? If you identify, how will you identify the host number? Just keep this Are you following? So how many subnets you can have in this? 3 bits are there for subnet. So you can have 2 to the power 3 subnets. 8 subnets you can have with this subnet mask. If I have give you this subnet mask, how many subnets you can have? You can have 8 subnets, and each subnet will have how many hosts? 2 to the power 5 minus 2, right? So there are how many bits for the host? 1, 2, 3, 4, 5. So 32 minus 2, each subnet will have 30 hosts, because 2 are reserved, one for with 0 and one for higher one, right? Followed? Okay, so this gives you this. So now if I say that and datagram arrives with the IP address 192.228.17.57. Okay, so if this is the datagram address, right? So this portion is same. So you can say that and once you do the subnetting with 57, okay, 57 is written as how much? How? Once you perform bitwise AND with this, the same subnet mask, 57 can be written as what? 57, 128, 64, 32, 16, 48, 8, 56, 0, 1, right? 57 can be written like this. 128, 64, 32, 16, 4, 2, 1, right? 8421. This is 52, 57, right? So if I apply this subnet mask on this 1, 1, 1, 0, 0, 0, 0, 0. So once I multiply this bitwise AND I perform, it is 0, 0, 1, 1, 1, sorry, all zeros, na? 0, 0, 0, 0. So contiguous zeros starts from this. So subnet number is 1, right? I got the subnet number, and from this 5 bits, okay. So I will keep, so in this 57, I will remove this 3 bits, right? And this will provide me the subnet, the host address. What is the host address? You please see 16 plus 8, 24 plus 1, 25. So if a packet arrives with an IP address of this, it is to be delivered on subnet number 1 and with a host number of 25, right? So if you see here, so if a packet arrives at that, it will be given on subnet number 1 with a host number of 57, right? So its host number is 25. Clear? Is it clear or not?
Yes, sir.
Okay. So either the subnet mask can be given to you, and you will be asked to find out the number of hosts or on each subnet, or there may be a possibility that it will be asked to create a subnet mask. I will say that there are 4 hostels, each hostel is having these many hosts, right? So design a suitable subnet mask, right? So such kind of questions can be given. So it is a subnetting. It reduces the complexity of the internet, right? It provides more IPs. So these IPs are used as a local label, right? So we somehow saves them addresses. Okay, it reduces the routing complexity. Is it clear?
Yes, sir.
Right. So now moving ahead. So this was about the subnetting, how the addressing is done in IPv4. So now moving ahead with ICMP. I told you about ICMP. I told you about that IP doesn't provide any guarantee. Okay, it doesn't provide any error control, flow control, but still there is a need to for feedback reporting, right? Suppose a datagram lifetime expires, a datagram has been dropped, right? So how the source will know, because there is no acknowledgement and other things in the network, so how the source will know that what action it has to take? So if in case a router drops a datagram because of some reason, right? Maybe the uh, datagram size is higher, so router has to drop a datagram because of some reason. So that reason needs to be specified to the source, then only that, and that your datagram has been dropped by the router, this information should be conveyed to the source, then only the source will retransmit that, right? So to take care of such eventualities in the network and to report the different uh, such type of eventualities in the network. So for feedback reporting, there is another protocol named as ICMP, Internet Control Message Protocol. It provides error and flow control in the form of messages. It reports, it gives the feedback about the network condition in the form of messages. So that is why it is called as a message protocol, right? It conveys some messages like you had studied earlier that how the congestion, when the congestion develops in the network, right? How the congestion, there are different mechanisms, right, for congestion clearance. So you had studied about choke packet. Have you studied or not?
Yes, sir.
How does it work?
The router sends the source the packet to notify that congestion is happening.
Right. So suppose if this is the source and it is generating the packets at a very faster rate, right? And router is unable to cope up with that flow, right? There may be other devices also, intermediate devices also. So router, what the router will do, because it has to request the source to slow down. Otherwise, unnecessarily the router buffer will be full and router will start dropping the packets, right? So what it does, it sends a message. You can assume that it's a choke packet. So it informs, to inform the source, it sends some kind of a, the choke packet में हम लोग क्या करते थे, it is send, a packet is sent in the reverse direction to the source, so right, so that the source once receives it slows down and router receives, the flow is adjusted, right? The network remains free from congestion. Similarly, here also the router will send a message back to source that the flow is exceeding, please slow down, right? So this works in the form of messages. So the messages are exchanged from router and host to host, right? So it provides feedback about problems in the network, right? See, generally we ask a question that why ICMP is a user of IP. It is said that ICMP is a user of IP. Can you say why? Because ICMP, uh, even though it's a companion protocol at the network layer, if you see, right, there is an IP, there is an ICMP. Both are in the network layer. Both are companion protocols. Both are at the same level of the TCP in the TCP/IP architecture. So both are at the same level. Both are companion protocols, but still ICMP is said to be a user of IP because all the ICMP messages, okay, which are routed in the network are encapsulated in the IP datagram, right? So all such messages to report problems in the network are encapsulated in the IP header. So that is why it is a user of IP, because ICMP uses the services of IP for sending the messages between host and router or between the two hosts, right? Now what are the different messages, right? So let me first say that okay, it is not there. So destination unreachable, right? There are different messages. There are two types of messages. There are error reporting messages and there are query messages, right? So these messages like destination unreachable comes under the category of error reporting. Right? So these are all coming in the category of error reporting. This is in IPv6 packet 2 week is not here. These are all error reporting messages, right? It is not in IPv4. While these type of messages, echo reply, this type of messages are called query messages, right? So what are these right? So the router sends this message to the host, indicating that if a router is unable to forward the datagram further, okay, either uh, because the router doesn't find that address in its routing table, or router or the station or the destination station may not exist on the network, okay, may not be available on the network, or the path is broken between the router and uh, the host, destination host, the link is unavailable. So in such conditions, the router will inform the source host that I'm unable to forward the packet, right? So it will drop the datagram and will send a destination unreachable message to the source, right? Let us first discuss all these messages, then we will see the header formats, right? So in such scenarios, it will intimate the source that the destination is unreachable and the datagram cannot be forwarded further, right? The other message is time exceeded message. This time exceeded message is used in which case, you know that we talked about datagram lifetime. So if the datagram lifetime expires, right, and a datagram is to be dropped by the router because it will not process it further because its lifetime is expired, right? So once the router drops the datagram, it informs back the source host that the datagram has been dropped because the time limit was exceeding. So just now so this was about the time exceeded message. We just now discussed about a choke packet. So source quench message is also the same, right? It also performs the same job. So whenever uh, the rate of fragments generated by the source overwhelm the router or the other, so in such cases the router sends a source quench message towards the source stating, asking it to slow down. So whenever there is a uh, flow is exceeding and it is the router is unable to cope up with the flow, then it sends a source quench message to the source asking for a slowdown, right? Parameter problem is another message. So wherever there is an issue in the header, suppose header got corrupted or there is some other issue, like because the checksum is calculated at each router, right? Each time a router process it. So during those calculations, if some parameter issue is there, because of that the router is unable to forward it. So syntax error, or you can say the parameter problem. So that because of that, it informs the source that there is a parameter problem, and because of that, the datagram was dropped. Now, redirect, right? So as I told you earlier that in a dynamic environment where we are talking about internet, so in such an environment, uh, there is always a possibility that new routes are discovered by the routers, right? I told you that what is dynamic routing. Dynamic routing is about an update, okay, and an update is always coming from the other routers, right? Whenever the other routers in the network shares the information with other routers, we will see that while we will discuss the routing protocols, that how the information flowed in the network, in which form the information flowed in the network, and how the routers updates their routing tables, okay, before making the routing decisions. So there we will see. So just for now, like there is a possibility that suppose in general way also, like suppose if I have a predefined path from moving from BIT to Ranchi, right? But if somebody else has explored a better way to reach, right, in a smaller time, and he just conveyed me that I know the other way is also there, so then I will also get updated with that. In a similar way, when any router finds a shorter route to reach to a particular network or particular network, then they update their tables, right? And once they update their tables, the updated tables are exchanged with the other routers, right? So the router comes to know that I can reach this particular network via this router. Okay, so whenever there is an update in the whenever the router finds a new route to reach a particular place, so that redirect message, right, it can convey the source that you should use the other way to go, rather than going sending it via me. You should use this updated, you should use this the other way to reach to this particular destination. This is a minimum cost route, or this is a better route, right? So that it will redirecting the source, right? Now coming to the query messages, right? There is a few query messages like echo request and echo reply. See, in an environment like in internet, if a host, right, a host wants to know the availability of the router, or the router wants to know the availability of the host, whether that particular host is alive or not, whether that particular router is alive or not, right? So it just to establish a communication, right, between the two hosts or between a host and a router, right? Anyone can send a echo request message. Echo request message is just like you send a hi to someone, and then if the other one replies back, oh hi, then okay, you know each other. So similarly, echo request and echo reply messages are same way, that's to exchange uh, some messages so that they know each other, and then they can communicate with each other, right? So whenever a host wants to know the availability of the router, or the router wants to know the availability of a host, they exchange echo request messages. So once a echo request message is sent by the host to the router, if the router is available, it will reply back with the echo reply message to the source. That is how a link will be established between a source and a destination, between a host and a router, right? So they can communicate further, right? To know the availability of the other uh, host, intermediate device, or a host, these messages are exchanged. Similarly, I told you that timestamp and timestamp reply messages. These messages are used, suppose you want to judge, or you want to note the delay characteristics of the network. So a host will send a datagram, a message with a timestamp on it. It reaches at the destination, so that you can see that here it originates timestamp, so it puts at what time this message was originated. Then once it reaches at the host at the destination, so originate timestamp, receive timestamp means receive at the destination host, and then once again a timestamp is put at which it is originating from the destination to source, right? So once it is going from destination to source, so in that way you can measure the delay in the network, the total delay incurred in the network. So or delay characteristics of the network, that how long it takes a datagram to move from there to there and from there to here, right? Similarly, the last two messages, address mask request and address mask reply, just now we discussed about the subnet mask, right? So if a router is not knowing the mask, if it is not aware of the subnet mask to be applied on the IP datagram, it broadcasts this message, address mask request. It broadcasts this message in the network. So so the other routers which have the subnet mask will reply back with this address mask reply message to that particular router. So in that way, the router comes to know about the address mask right? So these are the ICMP messages. ICMP is just to report feedback, gives the feedback about the problems in the network. So we will see the header part in the next class. So the next class is on Monday. So Monday class will be suspended because of the STF program, Science and Technological Festival, because the classes are suspended on that day. So I will not take on Monday, right? So the next class will be on Thursday. Because Wednesday we do not have any class. Monday is a holiday, right? Okay, thank you then.
Thank you, sir.
Thank you.